All right, the last type of factoring we are going to look at takes us out of the realm of factoring quadratics. So it should not be, it should just be factoring review. And we're going to be looking at factoring the sum and difference of cubes. We've already learned how to factor the difference of squares. And hopefully when we did that, you realize that there's no way to factor the sum of squares. Let's go in here and add a page. Move this around a little bit. Well, I'll just go here. Difference of squares. When you have two terms, both terms are a perfect square, like that. It's going to be the product of the sum and the difference of the square root of each term. So it's 2x plus 3, 2x minus 3. If this were 4x squared plus 9, we wouldn't be able to factor it because that's the sum of squares, not the difference of squares. So you can only factor the difference of squares. But you can factor both the sum and difference of cubes. I have gone back and forth about whether or not to show this method because what we're going to do is we're not going to look at the why it works. We're just going to look at the how to do it. If you really want to look into why it works, it's a really cool geometric explanation. You can check out this video right here. I'll have it linked in Schoology. But if you want to check it out, you're not responsible for it. But it will be a good idea to learn the algorithm. So we're just going to look at the algorithm. An algorithm is just a basic way of memorizing a process. So we're just going to look at the algorithm for factoring the sum and difference of cubes. So first we'll look at the sum of two cubes. It's pretty straightforward. It looks confusing, but it's not as confusing as it looks. The first thing you've got to do is recognize what your cubes are, your perfect cubes. So just think about 1 times 1 times 1, 2 times 2 times 2, 3 times 3 times 3, 4 times 4 times 4, 5 times 5 times 5, 6 times 6 times 6, maybe it's 216, and so forth. If you're not sure if a number is a perfect cube, I'm going to go check 216. You can go to your Desmos and then you can go to functions and you see a cube root or an any root right there. And we just want the cube root and we can check the cube root of 216 is 6. 7 cubed would be 343. So basically, when you recognize that it's the sum of two cubes, the way you tell if an exponent is a cube, it's just a multiple of 3. So x to the third would be a perfect cube, x to the sixth, x to the ninth, and so forth and so on. I just want to look at x to the cube, though. We're doing very basic ones here. So when you recognize that it's the sum of two cubes, the first factor is the cube root of the first number. So the cube root of x cubed is just x, and the cube root of the second number. You keep your sign. So if it's the sum of two cubes, you take the cube root of the first term, the cube root of the second term, and keep your addition sign. And then this second factor comes from the first factor. So for the second factor, we're going to take the a, the first number, and just square it. So in this case, it's going to be x squared. Then we're going to multiply these two together. So that's going to be plus 2x, but we take the opposite sign. So it becomes minus 2x. And then we square the second term, plus 4. And that's as far as you can go with that. That's the whole algorithm for factoring the sum of squares, sum of cubes. So let's look at this one. We're going to take, recognize it as the sum of two cubes. Cube root of 1 is 1. Keep your plus sign. Cube root of 64 is 4. Cube root of x cubed is x. So that first term is pretty straightforward to get. The second term, We're going to take the 1 and square it. The last term, we're going to take the 4x and square it. That's where the 16x comes from. For the middle term, we take these two and multiply them together, 4x, and take the opposite sign. So it's 1 squared minus 4x plus 16x squared. And again, this is just a memorized algorithm. So let's look at this next one. Recognize it as the sum of two cubes. We take the cube root of the first term, which is 3, cube root of the second term, which is x, and we keep the plus sign. And the second factor comes from the first. We're going to square the 3. We're going to multiply these two together and take the opposite sign. And then we square the last term. And if we were to multiply these two expressions together, we would get 27 plus x cubed. Let's try another one. Recognize it as the sum of two cubes. The first factor comes from the cube root of both of those, so it's 2x. Keep your sign, plus 1. Second factor comes from the first. So we take the first term and we square it, 4x squared. We're going to take these two and multiply them together and take the opposite sign, minus 2x, and then we square the last term, plus 1. And that's it. And that's as far as you can factor those. Let's do one more. 27x cubed plus 8, cube root of 27, cube root of x cubed, cube root of 8, keep your plus sign. The second factor comes from the first, so we're going to square the first term. 3x squared is 3x times 3x, which is 9x squared. The middle term, we multiply these two together, take the opposite sign, and then your last term comes from your constant term there squared, plus 4. And that's it. So it's probably worth noting that if it's the sum of two squares, sum of two cubes, you're going to have a plus sign, a minus sign, and a plus sign. It's always going to be that, plus, minus, plus. Notice it here, plus, minus, plus, plus, minus, plus, plus, minus, plus. Now let's look at difference of cubes. Very similar, but notice your sign. It's going to be the exact same process, just notice your sign. It's minus becomes a minus, plus, plus. Everything else is the same. So difference of cubes, we take the cube root of the first, cube root of the second, keep the subtraction sign. Then the second factor comes from the first. We take our 3 and square it. It should be 9. It's a typo, which I'll fix before I print it. Then we take these two, multiply them together, and take the opposite sign, plus 3x. Then we take the minus x and square it to get plus x squared. Let's try another one. Cube root of 8x cubed is 2x. Keep your subtraction sign. The cube root of 125 is 5. Then to get the first term, we're going to square 2x. 2x squared becomes 4x squared. 2x squared becomes 4x squared. Then we multiply these two together and take the opposite sign, plus 10x, and then we square the 5, or the negative 5. and that becomes plus 25. Same process. It's really just the exact same process. So let's try this one. Cube root of 8x cubed is 2x. Cube root of 1 is 1. Keep your subtraction. Now we're going to cube 2x. 2x cubed, we're going to square 2x. 2x squared is 4x squared. Multiply these two together. Take the opposite sign. Plus 2x. Square your negative 1. Plus 1. Let's try the next one. Cube root, cube root, cube root. Keep your minus. Square. Multiply together. Change your sign. Square. Last one. We just did this one. Let's make this one 125. I'll change it on the sheet before I print it. So this becomes 2x minus 5. And then we square this, 4x squared. Multiply these two together. Change the sign. Square the 5. And there you have it. There's some ones to practice on the back of this. And if you look in Schoology, the answer key is in Schoology posted. So there are your answers there for those. And that is the last bit of factoring we're going to do. We'll review the rest of today and Thursday, and then the summative will be Friday.